Okay, we're
It
almost
has to make us a
moving.
panelist, right? Yeah.
Are they
I don't think we're gonna break any chat records.
Is there an echo or is that just me?
Oh no. Through whose mic?
Oh wait, I didn't have it.
Hello, I think this is working now. Can anyone hear me?
Yeah.
All right, let me start streaming from here.
All right, send it.
Uh,
Are you just going to the end, by the way? Because you were on 53. This is like 50. The FRQ ends at 53, or ends at 52. There's a break. So are you just
Okay.
going from now to the end?
yeah, and then you can do the break. Or I can do the break if it's a Q&A.
Whatever, either
Yeah,
or, yeah.
I don't mind.
Okay.
All right, everyone see this? Is it good?
Yeah, we're good.
Oh no, this is the
we'll
wrong
need to...
tab. Hold on. This is the...
Yeah, it's
Okay,
the
I'm gonna
fourth one.
send out invite link. Hold on.
Yeah, send it.
Just AP stats sabotaging us.
Yeah, it is.
This is the one I want to share.
Yeah. Wait, you're sharing your whole Chrome tab.
Yeah, I don't... Can I just share this one
Hold
tab on Zoom, right? I don't know if I can do that.
Wait, what does the
hold
tab
on.
button do? That just showed up.
I don't think you can. I think you might just be stuck with your screen.
Yeah,
Okay, I just sent out the invite link, so I hope people can join. Okay, it looks like people are joining.
Wait, like 1 second. Why is this not showing up as a window for me to stream? All right, can you
Hi
guys see me?
guys.
Yeah.
All right, cool.
Yeah. Oh, it's so much clearer.
Yeah, just do raw window then.
Mhm.
Hi guys, welcome back. Everyone pop in. Oh my God, I just opened.
We're not breaking the chat record.
Pop in the chat. No, we might have.
We might have.
We might have, because everyone's broke right now, I
At the
think.
beginning, yeah. No, everyone's is broken.
Yeah.
It's not just us.
Oh.
So
wait,
We want to broken the 1 day record because
yep.
I think we're on
Makes
pace,
Can
bro. We're
they
definitely on
send
pace.
in
100%.
chat? Are y'all able to? Oh no, chat's disabled.
They said their chat's disabled. Okay, we'll work on that. Hold on.
Chat with everyone. Try now. Guys, try now. There we go.
Yes, there we go. Look at us go.
Okay.
Okay, we'll give everyone a couple more minutes just to make sure everyone's in here, and then we can start the FRQ stuff probably.
Yeah, let's just start when that is working. Kritika, is everyone here? Okay.
Yeah, all of us are here too.
Okay, so I'm going to leave the crowdcast one. Actually, I'll send the link.
All right, right now on your screen, what do you see?
Are you guys able to see the screen and everything? Like,
Me and 3 slides. What FRQ I became proud.
No, no, the three of us inside.
Okay.
Yes, guys. Okay.
We can see
We're good.
everything. Permissions Q&A for answering.
Okay. Yeah, hold on. Attendee. Wait.
Can you see my
Um,
mouse? Can anyone see my mouse?
Are you guys
Like I can
able
draw.
to?
You
Can you guys
Okay, great.
put?
That's great.
Yeah.
Can you guys use the FRQ section? I mean, it says that you can on my end.
Can you do that?
Yeah, you're good.
That's cool. That's actually better now. I can.
Yeah.
write
I know,
on both.
Loki.
Can you
Loki
guys
just-
Yeah,
can you guys
Loki,
use
it's
the
like you're
Q&A
good.
section? If not, or
I saw
hopefully.
someone answer a question before. Yeah,
Okay,
exactly.
yeah.
Perfect,
It
perfect.
works.
Lovely.
Oh, okay. Okay, nice. Okay. Yes, so we'll be able to, guys should be able to. I'm actually going to end the broadcast on Crowdcast. So from now you should be able to go back to that link and then see the recording. Right now this is being recorded, and then this link will be uploaded into your My Stuff thing by tomorrow probably. And in order to make up for time, we will be here over the 10 p.m. EST original like block that we had. So yeah. So we'll now go on to the answer of the FRQ. So focus up.
All right. What's up, everybody? Let's knock out the FRQ, guys. All right. So getting started again. We have a volume of 30 mils of 0.1 molar NH3 is titrated with 0.2 molar HCl. The value of the base dissociation constant, Kb, for NH3 in water is 1.8 times 10 to the negative 5 at 25 degrees Celsius. Since we know that we're at 25 degrees Celsius, that assumption that pH plus pOH equals 14, Kw equals 10 to the negative 14, all that stands, and we can go ahead and use that if need be in our problem. So the first problem is relatively straightforward. Part A just requires us to write the net ionic equation for the reaction of NH3 aqueous with HCl aqueous. So of course, we can just start off by actually just writing out NH3. Wait, I didn't mean to do that. Hold up. Okay. I'm trying to like annotate for you guys. 1 second. Can I not do that? Where? So, okay, can you see that? All right. So NH3 plus HCl. But here we have HCl as aqueous, so is NH3. So we can really write NH3 aqueous plus H plus aqueous plus Cl minus aqueous, right? And that gives us, well, these two combine, NH3 and HCl. That gives us NH4 plus aqueous plus Cl minus aqueous, right? But if you notice, there's Cl minus on both sides, so we can cross that out. This problem, yeah, it can count as an equilibrium, but it's probably going to count more as acid base. And so we're left with as our answer, just NH3 aqueous plus H plus aqueous gives us NH4 plus aqueous. All right, that's it. So that is our answer, and we can check that by seeing the next pop-up, which confirms that to be true. You don't need the phase designations, as someone in chat did say it. But yeah. All right. So this is the part where I think it'll be really helpful that we have the ability to draw on the curve. So, guys, please put Q&A. Yeah. When should we use the KB given? I'm gonna let you guys and the other co-hosts answer the Q&As. If any of them are pressingly important, just put them up on my screen or like speak up and I'll answer it. Okay. So let's start with this now. All right, so to draw out this titration curve, right? Initially, right, at the very start of this thing, all we have is 0.1 molar NH3 in a certain volume of water. So in NH3, put in chat, guys, is it basic or is it acidic? Basic, exactly. That means pH is going to be greater than 7 or less than 7. Greater, exactly. So when they ask you to draw graphs, they don't usually want exact values that require tons of calculation. We can just put it up here somewhere. We can say we start over here. This is where our pH initially starts. And as we add HCl, our pH will decrease and decrease and decrease, right? Until we get to some point where we're at the equivalence point. So let's go ahead and calculate the equivalence point right now. So to calculate the equivalence point, we just have to do M1 V1 equals M2 V2, right? Because as we know from part A, we have for each 1 mole NH3, we have 1 mole H plus. So it's 1-to-1 reaction. So the molarity of NH3 is what? 0.1 molar. The volume of NH3 is what? 30 mil divided by the molarity, M2. We can go ahead and write this. M1 V1 divided by M2 equals V2. This is to calculate our equivalence point. And what's the molarity of HCl? It's 0.2 molar. This should give us 15 ml. All right, so that's our equivalence point. So we can say that at the equivalence point, we'll know the equivalence point happens here. All right, and from that, we know the half equivalence point. All right, the half equivalence point is just this divided by 2. So we divide by 2, half equivalence point equals 7.75 7.5 ml. My bad, guys. Sorry. 7.5 ml. All right. So at 7.5 ml, you have the half equivalence point. And what do we know about the half equivalence point, guys? What do we know? pH equals pK, right? Here we have the Kb. So to find Ka, what we do is we say Ka times Kb equals Kw equals 10 to the negative 14, right? From this, Ka equals 10 to the negative 14 times 1.8 times 10 to the negative 5. And someone do this in your calculator. This is pretty likely to come up in FRQ. I got 5.6 times 10 to the negative. Instead of 15 divided by 2, shouldn't be 30 divided by 2. No, it should be 15 divided by 2 because your equivalence point is 15 ml, right? Because you have different concentrations. 5.6 times 10 to the negative 10. Yep, okay. That is what I got too, right? And so that means your pKa, taking the negative log of that, what do you guys get? Because I get 9.26. The equivalence point is 15, calculated from M1 V1 times A equals M2 V2, right? So at this point, you know that your pH has to be 9.26, right? And the pH has to change sharply in this region, right? That's probably a little bit too wide of a change. Probably till here. And now you just connect the dots. Just connect the dots, right? So you can just connect the dots to find that your titration curve should look kind of like this. And now all of a sudden, the pH goes down really low. And that's kind of look like. Because as you add more HCl, all of a sudden the solutions become very acidic, right? You're just connecting dots. You're finding the important points and you're just connecting dots afterwards. I think we have some Q&As. How would you go about this if it wasn't a 1-to-1 ratio? This would just be modified. This would just be modified based on the stoichiometric ratio. Okay. We don't need to, I seriously doubt they'll make you find initial and final pH. It just takes too long. How do we know initial pH again? We just said that it's kind of going to be basic because obviously ammonia is basic, NH3 is basic. We did not use an ice table to calculate initial pH because that takes too much time. All right, let's move on to the next slide. Well, there you go. Let me delete. How do I delete everything? The graph should never touch the x-axis. Yeah, because that's like infinitely, or not infinitely. That's a pH of 1 molar, and that's like pretty basic. Let's clear all drawing. Okay. All right. No, at half equivalence point. Yes, it's at half equivalence point. pH equals pK. So there you go. You guys can see this scoring guidelines. The first pH has to be greater than 7. So the second scoring point has to be getting the right equivalence point. And the third point has to be getting a pH at equivalence point being less than 7. Again, we found this because we just connected our points, but we know this to be true from what Rahi talked about earlier, where if you have a strong acid and a weak base titration, at the end, at the equivalence point, you will have excess weak acid left over, right? So your pH will be less than 7. All right, I think we're good on this, so we can move on to the next question. All right. So now that we know the graph, right, we have to find the most appropriate indicator for the titration. So we know that at the endpoint, we're going to have pH around 5, right? We don't necessarily need to know that it's 5. We just need to know that pH will be less than 7 at equivalence point, right? So we just need to have a pH of change here, a pK less than 7, right? Because we want to see the change occur when we reach the equivalence point. And out of this, the only correct answer is methyl red, right? So this is a freebie point if you can get the previous question. Alrighty, let's move on. Let me clear all my drawings again. All right, next question. All right, this one looks scary, right? Because now you see all this stuff and you're going to be like, I need to use Henderson-Hasselbalch for this, right? But you don't have to go fully there. Right now, you look at this question and you see that you have equal volumes of 0.1 molar NH3 and 0.1 molar NH4Cl. And you're asked whether the solution is acidic, neutral, or basic. All you're left to do is you have to recognize that in the solution, NH3 equals NH4Cl, or NH4 plus, sorry, right? So because the Henderson-Hasselbalch equation says that pH equals pK plus log NH3 over NH4 plus, but these two are equal, this whole thing cancels out, right? Because log of 1 is just 0. So we can write that pH equals pK. And remember from part B, we found that pK equals 9.26, right? So that means that pH equals 9.26. Simple as that, right? And is 9.26 acidic, basic, or neutral, guys? Basic, exactly. So that's it. At me. Sorry, I'm doing it on mouse, but if my handwriting is not up to scratch, just let me know. I can go a little bit slower. So yeah, if you can't understand what I'm saying, just tell me. All right. But that's it. It's not, but it's cool. That's good. Okay, good. Oh yeah, same idea here. Yep. Can I say that, okay, this is a good question. Can I say that it's basic just because NH3 is a strong base? No, NH3 is not a strong base. You cannot use that justification in the first place, but you can say that it's a stronger base than NH4 as an acid. We know that the pK is 9.26 from the formula. Let me write it out. Ka times Kb equals Kw. And we can calculate Ka from this because they give you Ka from this because they give you Kb. Our titration is always on the FRQ. You can probably bet that at least something about it is going to be the FRQ. Our calculations can serve as justification. Yes. Okay, I'm going to move on from this to the next slide. Give me a second. I'm not sure. All right, but we have a break. We have a break. Rahi, do you want to explain what was the last slide?
I think Anuva wants to explain a little bit more. Dude, what was that?
Anuva, what was the last
Hello?
slide?
What do you mean?
Biggest stray of my life, I can't lie. What is this? Because that one person
I
that said
feel
I
like
looked
I
like I
could-
was talking to a brick wall, right?
Yeah.
That's crazy. That's messed up. Anyway, 9-minute yap fest. Me,
Mhm.
Yash, and Anuva, I guess.
Yep. After this, we're playing a quiz, guys. So get excited. Get excited.
She's not saying I'm a brick. Someone said that I was talking
He's
to a
got the
brick
IQ of 1. It's
wall.
okay. It's okay. Samosa soon, guys.
Samosa
The
very
most soon, exactly.
Exactly.
Given that the audio does come.
No. I'm not calling you guys a brick. I'm calling Rahi a brick.
Oh my god.
Like every single group meeting that we have afterwards, it's like I feel like I'm talking to a brick wall when I'm talking to Rahi.
How?
Because it's
Deep
just
down,
like
we're all
not
a brick,
clicking up
that's
there
real,
for
that's
you.
real.
Yeah, okay. Okay.
All right. The M1V1 equals M2V2. That's just saying that remember at the equivalence point, moles of initial like acid or base are equal to the moles of acid or base added. M1 times V1 is just the initial number of moles of base NH3. And M2 times V2 is just the moles of acid HCl added. So those two have to be equal, right, at the equivalence point, because that's literally the definition of the equivalence point. Right, there's a lot of Rahi hate in the chat going on.
Yeah, come here. Oh my god. I don't even know what to say. By the way, there's no, okay, so to answer a couple other like Q&A questions, there's no, we cannot post like the work that like Yash did because it was like annotated and then cleared. So we can't post that work, but it's relatively in line with like the work that you just generally see on the slide as well.
Mhm.
Okay, it's more or less completely in line.
Also, so I said this before, right, when we got into Zoom, but for anyone who came in like later, so this is gonna function the same way night 1 did, where we'll have the recording uploaded once the stream's over. So for the first half when we talked about like before the whole crowdcasting got crashed and everything, we ended that stream. So if you go into my stuff, you should already see that recording. But for
Ooh,
the
I really
Zoom,
thought we were in the clear, y'all.
what happened?
What happened?
I was really like, I was feeling good. I was like, yay, what a night.
Oh, like crowdcasting? Yeah,
No,
I
this
know.
has been bad. This has been bad. But just to continue what I was saying is like the link will be uploaded for the recording after this stream, and it might take a little bit because we have to like physically put in the recording link into your My Stuff stuff. Yeah. But yeah, Jess, you're so real.
Yeah.
All right, okay, let me do some Q&A. We have, what are all the equations that are valid at 25 degrees Celsius?
You guys, every day, a new adventure.
Yeah.
Jess, I'm just gonna say I think you're unmuted, so
Yeah, I don't know if that was
Dude,
intentional
I
or
was
not.
like,
Stream.
uh-oh. And then I was like, okay, they're all here. We're okay.
I'm gonna mute her. I'm gonna mute her. Okay, you can, Yash, you can keep going.
Okay. So at 25 degrees Celsius, KW is going to equal 10 times 10 to the negative 14. And all the things that flow from there, such as pH plus POH equals 14, are valid at that 25 degrees Celsius. So yeah. How do we know if we need to use the equation M1V1 equals M2V2 when you're calculating equivalence point? All right, I don't know. Let's make this a 3 minute, 2 minutes left in this break, or 3 minutes left in this break, because we do need to get going. TBH, I'm still kind of unsure of my abilities to recognize buffers. Could you give me some tips on easily recognizing buffer solutions just based on the equations? Yes. Okay, so first of all, like make a list in your head of all the different things that are in the solution right now, and have those things react with each other in the way that you think they would, and then have a list at the end at equilibrium. What is all the crap that is in my solution. If you have a conjugate base and an acid, or an acid and conjugate acid and a base, you have a buffer solution. In the last question, why don't we just consider NH4Cl as a weak acid? We do consider it as a weak acid. If it's a weak acid plus a weak base, isn't the pH 7? No. The pH in a weak acid, weak base solution depends on the relative strengths of the weak acid and the weak base. Wait, so how do you calculate half equivalence point again? Also, when can we use the M1 V1 equals M2 V2 equation? All right, again, yes, sure. The M1 V1 equals M2 V2 equation can be used when you're calculating that half equivalence point, right? Or that equivalence point. And to find the half equivalence point, just take the equivalence point, that volume number, and divide it by 2. So if the acid and conjugate base, or vice versa, are on opposite sides, it's a buffer. If the acid and conjugate base, or vice versa, both exist in the solution at the same time, it's a buffer. How can you tell whether something is a weak acid or weak base if the Ka or the Kb respectively is much, much less than 1? All right. I'm literally popping boba out of a container. Trenches. The trenches for sure. All right. A buffer is a solution in which both an acid and its conjugate base, or a base and its conjugate acid, exist simultaneously. They behave in that region when you have a buffer, the pH doesn't change too much. We'll do a lot of questions on it. By looking at the compound, can you tell if it's weak? Eventually you can, but for now, just use the Ka value they give you. Wait, I am laughing at the host messages. I thought that was for everyone. Okay, let's play the quiz now.
I'm literally eating popping boba out of like a container. It's like so trenches.
Wait, I've done this
Like
before.
I'm not
I've
even
done this
drinking.
before.
I'm not even drinking like actual boba. It's like genuinely just like the pearls. Like
I've done this before. I went to like a boba shop first, like when it was like closing, and they were like, "Yeah, we throw our popping boba at, like away at night."
Dude,
And
I
was
don't
like,
want
dude, listen.
I don't like popping boba in drinks, but like, okay, hold on.
You
Danica
don't?
and Kritika, I don't want to hear it. Guys, I don't want to hear it because you guys work under me and I'll fire you.
Okay.
Let me just put
Okay.
that there.
Jessica, get on this. We need her out. I'm unionizing. I'm
All right,
unionizing.
everyone, make sure you guys are joining the 5-able quiz. Make sure.
Guys, if you get more than 80, like if hold on, how should I say this?
Can you guys
if
hear
more
the
than
music?
80% of you guys get no, we can't hear it. We
Okay,
may have
I'm
to
not
screen
playing it.
share.
I don't think you can hear on Zoom, like, because you can't
No, yeah, I
screen
don't
tab.
No.
Zoom audio
You should
is
be able
weird.
to.
You can, but like it's kind of funky.
All right, anyone know how to? I can try to do it while they're joining.
Let me see. Hold on.
Guys, no way. No, I'm not just mean. You guys didn't enjoy the joke that I made of Rahi's like brick wall meme.
Wait.
Guys, we're trying to figure out samosa, don't worry.
All right, can you hear the music now?
That's so real. No, we can't.
Can't.
No.
Can you hear it on your side, like while you're in the quiz?
No.
No.
Oh, no, I don't think so. No, try sharing like just the tab. Can you
I
like
don't know.
share
I don't
just
know.
the
There's an
tab?
option on Zoom for just the tab.
I think
You should be.
can.
So I think there's somewhere in the Zoom options is also like an audio sharing option.
It might
Okay,
be an
share
advanced
sound. Yeah, share
sharing
sound. Okay.
Yeah.
All right. Can you guys
There
hear
you
it?
go. There you go.
Yeah. Thank you guys. Yep. All right.
Yeah,
Great.
of course.
All right. We'll start soon.
Guys, do not call me the op. I will ban all of you guys.
She's the op. She's the op.
The link isn't working. Try this link.
Dude, she's eating boba
Guys,
with a
for this-
spoon.
for
She's
the-
eating boba
guys,
with a
guys,
spoon.
guys.
She's eating boba with a spoon.
Rahi, I don't want to hear it. You literally just said you did the same.
No, I like put it in. I made my own at home and I put it in drinks.
Guys,
like, at
for
home.
the next question, if more than 80% of you get it right, then Rahi keeps his job.
Hello?
Ooh.
Excuse me?
All right, guys, you guys better get this.
Anyways, bye.
Guys, get it wrong. Okay, that's not very nice.
Right, that's
You also
actually
send this
messed
to the
up.
host and panelists. Make sure you're sending it to the right chat. Ronnie does it. Alrighty. Big reveal, guys. Will it be above 80% correct? Big reveal. 3, 2, 1. 1/2. Alrighty,
Wow, I'm
95%
actually-
correct.
We're firing
Good job to
Anuba now.
say.
We're firing Anuba. We're firing Anuba.
Yeah.
Anuba's out.
All right, you guys seem to have gotten this one pretty well. The endpoint of a titration between a strong acid and a strong base, again, the equivalence point will be around 7, because that is a neutral solution at equivalence point. Yeah, phenolphthalein has a pK around 9, so it does change color in that region around 7.
90% for Anuba to keep her job this time.
90%.
Guys, y'all can't fire me. You guys don't have
90% and I get
Power.
Jessica on the
90%
job.
or
Guys, guys, for
90% I
this
get
one-
Jessica on this.
Well, up there.
guys. Guys, this next one, Yash. You better get 80% right.
All right. They're definitely gonna get them right. This one for sure. Have trust in the students.
Exactly. I think. Oh no. never
Ginika just
mind.
wants to keep her job. Where'd Samosa go?
Guys,
I'm not sure actually.
Jessica just left.
Can you not
I'm
hear
the
it?
host.
Yeah,
now.
she's getting the
Okay.
paperwork ready to fire like Anuba. It like, takes a little bit of work behind the scenes. She had to leave to go get the paperwork ready, you know?
All right. Good job, guys. Good job.
Okay.
All right. NH3 is a base. It's a weak base. It's gonna form NH4 plus ions. That's its conjugate acid. You guys seem to have gotten that one correct. Pretty high rate. All right. I don't think we're gonna do all the questions. I think we'll go up to like maybe 7 or 8, and then we'll stop and move on to unit 9, our last unit of content. Nervous laugh. Okay, bro. We are doing FRQs and just kind of whatever practice you guys want to do tomorrow. Wait, let's not do this question. We're only doing like up to question 8, so. New question, guys, new question. That last question was not part of this. How long will unit 9 take? We'll probably be here till at least 10-15. The Kawhi Leonard laugh. Do I sound? All right. It's okay. He's going all the way next year. Don't worry.
Yeah, he is.
Clipper's going all the way.
Next year.
All right. Great job, guys. Whenever you see a P, it's just negative log. So yeah. pK, pH, pOH, negative log of whatever quantity. Why doesn't he want to play? Yeah.
Guys, I might have really good news. We might have tomorrow on Zoom.
Yeah,
Oh, completely?
Exciting. That'll be good for the FRQs.
Yeah.
The hair care. I don't understand all the hair compliments.
Guys, suddenly everyone's gonna be gone tomorrow if you guys don't get more than 80% right.
Everyone is crazy. Anuba's actually gonna be solo teaching night 5 because all of us are gonna get fired.
Alrighty. Night 5 and self-studying, yeah, maybe.
Yeah.
Depending on how you guys
A
do.
silent 3 hours. You know those like lo-fi beats, the 10-hour ones on TikTok? I throw one of those on.
Okay, so this one was significantly harder.
Who's
for
losing
us.
their job?
All right, no. That's all right. Listen. Okay, a student adds solid NaOH to water until it reaches its saturation point. So its saturation point is the point at where no more NaOH can dissolve in the solution. Even if you add like crap ton more, the solution's concentration of NaOH and in that case, OH minus will not change, right? So that OH minus is going to remain constant. And if that OH minus remains constant, the H plus is also going to remain constant. And that means the pH will remain constant. The pH will not continue to increase because no more NaOH will dissolve. Guys, you need to focus because all of you guys got this wrong. So like, please focus. Rahi will be back. Don't worry. Does that question make sense to you guys now? Saturation is the point where something cannot ionize anymore. That is right. Yeah. Can I re-explain it? Okay. At saturation point, no more NaOH will dissolve, right? No more is going to dissolve, so the OH minus concentration will not change. Since the OH minus concentration will not change, the H plus concentration will not change, and therefore the pH is going to remain constant. It precipitates because you've reached the saturation point. At the saturation point, no more can dissolve. This is equilibrium. Yeah, good. Read the whole question. Yeah. Also, some of you guys are typing straight to hosts and panelists. Make sure you're typing to everyone. Everyone can see your wonderful insights.
I'm back. That's what happens every time. That happened every time you screw up a question. What the caprese that? Got food.
Rahi, watch this.
Yeah, what?
No. Send him the invite. Hey, Rahi's in chat. What did you do to him? Did you demote him or something? Like make him just a normal member?
I pressed change him to panelist and then it kicked him off.
Oh. Alrighty, guys, come on, let's get some answers in. How long will, okay, but we already answered this one. Come on, guys, get the answers in, 90 seconds per MCQ on AP Chem quiz. On the AP Chem test, sorry, exam. Can I explain this one? Yes, I will explain this one after we do the answer for it.
Rahi, literally turn on your camera. I made you co-host.
Oh,
Don't
it's
lie
fine
to
now.
me.
It's fine now. It's fine now. It's fine now. Hello, I'm back.
No, I misclicked. Okay. It's okay. Doesn't matter. Don't misclick on tomorrow or day after tomorrow. All right. This one was also a slightly difficult question for us. All right. So what change would occur to both H plus concentration and electrical conductivity after adding solid sodium hydroxide to pure water? So when you add an ionic solid to water and that ionic solid dissolves, your water is more conductive, right? Because you now have these ions that are floating around in solution that when you that can conduct electricity, right? So of course the conductivity would increase. You guys seem to have picked up on that at about 80%. But when you add OH minus, what are you doing to the pH? Are you increasing it or are you decreasing it? Put in the chat, guys. You add OH minus, are you increasing or decreasing it? Yep, you are increasing it because OH minus makes the solution basic. So if you increase pH, that means since pH is equal to the negative log of H plus, if you increase pH, that means H plus is going to go down. So there you go. The H plus decreases and conductivity increases. The conductivity increases because you're adding an ionic solid. That ionic solid is going to dissolve in water to form free-flowing or free-floating ions, and those ions can conduct electricity. All right, second to last question before we get started. All right, okay, never mind. This is our last question. Actually, let's not do this one. This is a pretty mid question.
Said that's a mid question and skipped it. Said that's a mid question and skipped it.
I don't want to do
Guys,
good
do not
questions
do
for
that
you.
on the AP exam. Do not do that on the AP exam. Oh, wait, if I make Yash spotlight, what does that take down the stream?
Maybe.
Yes, I think so.
Maybe
I think
just
it, like,
puts the
spotlights
stream
his
off to the
face. I think it
side,
makes
like-
his face bigger and like
Yeah.
throws off his screen.
Okay, I'll do that after. I'll try it out after this.
Yeah.
Thing. Okay, guys, I just got a note from my boss. So tomorrow
fired?
we're gonna be on. Actually, Rocky got fired, so you guys won't be seeing him tomorrow. We're actually gonna be hiring a new person to fill in his spot.
Put your application in chat. Put your application in
Oh,
chat.
that
guys.
application in chat.
Drop the application in chat.
Drop the resume. Drop
Send
the
the link
link.
in. You, it
Drop-
might
send
be
the
you.
link.
It might be you. Okay, but on a real note, so tomorrow everyone's gonna join the crowdcast, but we're not actually gonna use the crowdcast. There will be a CTA, so like there will be a little green button below, to have the link for the Zoom. So you go to crowdcast, and then there will be another link that you can press on, and then you can come to the Zoom, and we'll be doing our thing on Zoom.
All right, sounds great. All right, let's see what you guys did.
Actually,
for this
I'm
one.
taking Rahi's paycheck and then spreading it to everyone who's in chat right now. We'll be
Everyone
equally
who's in chat,
distributing it.
100 people.
Everyone's
Y'all
getting
want like
$5.
a good cent each or something? Yeah.
All right, pretty good, pretty good. So these buffer questions are super common on your AP exam, and let's boil this down to really like the basics of buffers, right? You have a buffer solution of NH4 plus and NH3, right? Now you know that when you have a buffer solution, the pH is not going to change much when you add either a strong base or a strong acid, because that's the whole point of a buffer solution, right? To not have the pH change much. So you can rule out B and D because the pH does not experience a large change. And now you're adding a small amount of hydrochloric acid, right? So the pH, hydrochloric acid is an acid, right? So the pH is going to go down just a little bit. Since it's a buffer, it's not going to go down a lot. It's just going to go a little bit. So the pH will decrease slightly. Yep. All right. So I think we're done with the Cram quiz for today. And we're going to get started on Unit 9. So yeah. Can everyone see my
Wait, let me try to
Screen.
put you on spotlight.
I think it just makes my face really big.
Okay, that's good. Okay,
The
there we
host
go.
has
I think it's
spotlighted
just
your
now
video.
you.
Okay.
So now I can only see you. Okay.
Everything look good on your guys' side, guys, in chat? I did this unit for the first time yesterday. That sucks, man. That sucks. Can you guys all see the slideshow like well enough? Okay, great. All right. So Unit 9 is application thermodynamics. It's 7 to 9% of the exam. So there are a lot of random stuff squashed into this unit. Entropy, Gibbs, thermodynamic versus kinetic control, coupling reactions, and electrochemistry. If you have not like studied this unit in school yet, I would recommend you take pretty detailed notes and really pay attention to this, because it's kind of getting to the point where you guys, some of this content is going to be new to you. All right, so let's start with an introduction to entropy. So entropy, before we understand entropy, we have to understand the laws of thermodynamics. There is a 0th law, but not important right now. Let's start with the first law. Energy cannot be created nor destroyed. Really simple, right? What goes in must come out. Energy can only be converted from one form to another. Second law is all about entropy, right? In any process that's thermodynamically favorable, you will see an increase in the entropy of the universe. When you see entropy on the AP exam, you're usually going to see it referred to as entropy of the system. The entropy of the system can still be negative, and the reaction can be favorable. The entropy of the universe just has to be negative or positive for the reaction to be favorable, not just the system. Third law just tells you that the entropy of a perfect crystal is 0 at absolute 0. And absolute 0 just means 0 Kelvin. Since we can't actually get to absolute 0, all standard entropies have to be greater than 0. That's actually not a true statement. I don't know why that's on the slides. Ignore that statement. All right. Entropy is a measure of disorder or randomness. Okay. Very simply, the more random something is, the larger its entropy is. Right. So we have a very small value of entropy. The system is really well ordered. Think like ice. You know those perfect repeating crystals of ice? That's ordered. Diamond. Think that those very ordered crystals are low entropy. Solids, therefore, are low entropy. Right. Now, if we have high entropy, that means the system is more disordered, right? Think gases, just random stuff flying around everywhere. That's high entropy. So based on this, we can put up a sort of ranking system. We have gas has more entropy than liquid, which has more entropy than solid. Note that gases have way, way more entropy than liquids do. At a higher temperature, there's higher kinetic energy, which means those molecules are going around faster and crazier. And so you have more disorder and you have a higher value for your entropy. Entropy is like formally defined as the number of possible microstates in a system, but you don't have to worry about that. All right, let's do some practice problems. The second half is so confusing. What are you talking about the second half? All right, whatever. Let's do these predicting the signs of delta S. So do number 1. Let's see. Is delta S greater than 0 or less than 0? Delta S is less than 0. Okay, perfect, guys. Because why? You're going from a liquid to a solid, right? Water to ice. Liquid has more entropy than solids do. Cube of sugar dissolves in hot tea. More, I'm seeing more. Okay, great. That's great. Because guess what? The system is going from this perfectly ordered sugar cube to a bunch of random sugar molecules floating around in water. Number 3. More. Yep, that's right. You're increasing the temperature. Things are going to move around faster. Things are going to move around crazier. So there's going to be more microstates, higher entropy. This reaction. C2H2 is hydrogenated with 2 moles of H2 to form C2H6. Less. Okay. Yep, that's exactly right. Because you have 3 moles of gas on the reactant side forms 1 mole of gas on the product side. So you're seeing less moles of gas. So you're seeing a decrease in entropy. All right. So here's absolute entropy. Remember that for a perfect crystal at absolute 0, the entropy is 0. That is not a true statement. Ignore that statement right there. I don't know why it's still there. Standard entropy is basically just the measure of disorder at a specific temperature. Entropy versus enthalpy. Enthalpy changes are the changes basically in heat at constant pressure, while entropy is the change in disorder. So looking at this chart, right, we can see that if we're comparing diamond to something diamond, a very, like if you remember the structure of diamond, it's a bunch of carbon atoms in a very well-organized structure. So we know the entropy for diamond is going to be really small. It's also a solid, really small entropy. But if we have something crazy random, right, like a nitrogen gas, just nitrogen molecules flying around everywhere, we're going to see that entropy is going to be almost 200 joules per Kelvin mole, right? Because there's just more ways the gas can be moving around, more possible microstates, so higher entropy. All right. let's do a practice question. We're just gonna make this a 1-minute timer, but for this reaction indicated over here, actually no, this is a math question. Let's make it 2 minutes. For this reaction right here, Pb, lead nitrate plus 2 moles of potassium iodide forms solid potassium iodide plus 2 KNO3. Imagine that's KNO3. What is the approximate standard change in entropy? Imagine that's KNO3, and that's also KNO3. And that's just K, not. Right, this is a bit of a jank question, but just bear with us. Imagine that's KNO3. I can just edit it on the slideshow like that directly. Oh yeah, sorry, lead iodide. My bad, guys. Lead iodide. Yep, you guys are saying in chat, and that is correct. It is A. It's just entropy is always equal to the entropies of the products minus the entropies of the reactants. Yep, exactly. Good job. All right. Gibbs free energy is possibly the most important thermodynamic quantity in terms of applications. So Gibbs free energy is just the leftover free energy available to do work. But you're not going to define it like this in AP Chem. You're just going to say in AP Chem, Gibbs free energy is equal to the enthalpy change minus temperature times the enthalpy change minus temperature times the entropy change. Sorry, guys. Been talking for a while. So delta G equals delta H minus T times delta S. You'll also see it. That equation's on your reference sheet, I believe. Now remember that delta G is a state function. So you can also use the products minus reactants. You can also use Hess's law to calculate delta G. Same with delta S. I don't know of any equation where it's reactants minus products. How could you use Gibbs free energy to answer FRQ? We'll be going over that just now. All right, so if delta G is less than 0, that means that we have a thermodynamically favorable process. This can also be called a spontaneous process, but AP actually likes to use thermodynamically favorable nowadays. So those of you guys in the chat saying bond associated energy, that's not exactly the same thing. It's a little bit different in that case. But if you want to think of it that way and that helps you remember it, that's cool. So remember, for the important thing for delta G is that if your delta G value is negative, your reaction is thermodynamically favorable. It's going to go forward. Now here's a really, really important chart for you guys, all right? Remember, you always want to make delta G less than 0 for it to be spontaneous, right? Now, let's do some examples. If your delta H is negative, for example, you have an exothermic reaction. Can I write spontaneous FRQ? Probably get away with that. If your delta H is negative and your delta S is positive, your reaction will always be spontaneous, right? Because delta G will always be negative. Now, for example, if your delta H is positive and your delta S is positive, your delta G depends on temperature, right? If your temperature is really small, that delta H will dominate and your delta G will be greater than 0. If your temperature is really big, that negative T times delta S will dominate and your delta G will be less than 0. And so your reaction will be favored at high temperatures. Conversely, if your delta H is negative and your delta S is also negative at low temperature, that delta H will dominate and your reaction will have delta G less than 0. And so your reaction will be favored at low temperature. Conversely, if you have high temperature, that negative T times delta S will be favored. And since delta S is less than 0, that's going to be a positive number. So the big positive number makes delta G a big positive number, which means that the reaction is all of a sudden non-spontaneous. Now, as our last row says, if we have an endothermic reaction, as in our delta H is positive, and we proceed with a decrease in entropy, as in our delta S is negative, delta G will always be positive. So the reaction will always be non-spontaneous or not thermodynamically favorable. You can check these, and I actually recommend you guys check these by doing the math yourself with random numbers. What's considered a high or low temperature, and is 298K high or low? 298K, so high or low, just assume that means high enough. That low just means low enough for that change to occur. Don't really get too tripped up on the exact numbers. Yeah, exactly what Rahi just said. And a really important note when you're actually making this calculation, right? This delta G equals H minus T times delta S. Yeah, I'll try to write it down with my pen. But you'll usually get delta H. The units will usually be kilojoule per mole, right? And for delta S, you'll usually get units of joule per mole Kelvin, right? So make sure you watch, because this is subtraction, right? So you want to convert, you usually want to convert this to joules per mole. So you can do this subtraction operation without having to worry about units too much. So make sure everyone notes this. This is if it asks you to calculate a delta G, make sure you do the unit conversions. All right. All right. You're welcome. Let's go to the next slide now. 1 second. All right. Here's a super important idea in chemistry. It's thermodynamic versus kinetic control. All right, in chat, let's answer this question. Which reaction has a smaller activation energy barrier? Reaction A? That's right. So which reaction will go faster? Yep, A will go faster because the smaller activation energy. But which reaction is more favorable? A or B? You're right, guys. B is more favorable because the products are stabler than the products of reaction A. So in this case, even though like reaction A happens faster, B is more stable. So it depends. It depends, like what products are produced will depend on your conditions and stuff. For example, like for a classic example is hydrogen, oxygen. Like hydrogen, oxygen together make a really stable product, water. But this reaction, I can tell B is more stable because it has a lower energy at the end. Hydrogen and oxygen together are really stable. They make water, right? But when you have hydrogen and oxygen together in a closed container, they're not going to react because the activation energy for hydrogen and oxygen to come together and actually react is really high. That's why if you ever done the experiment where you take that hydrogen balloon, you have to add a little bit of fire to get it started, a lot of high energy fire to get the thing started. So just because a reaction is super thermodynamically favorable does not mean that you'll actually see it occur. Classic example, diamond to graphite. So this reaction is actually completely thermodynamically favorable. Delta G is less than 0. But if any of you guys have seen a real diamond ring, you notice that the diamond ring, or I should do my ring finger, right? My ring finger. The diamond ring does not suddenly turn into a graphite ring, right? Has anyone's diamond ring turned into a graphite ring? Put it in chat if yours has. Yours did last week, okay? Yep. All right. This process does not actually happen, right? Because the activation energy barrier is so large that you're never ever going to see this really happen in real life. Unless you actually survive for a really long time. So the big takeaway from this is that spontaneity alone does not indicate anything at all about the rate of your reaction. Natalie, so I saw that question. So when delta G is negative, it is thermodynamically favorable. Yes. We do have a bunch of liars in chat. Yeah. Unfortunately. All right. Free energy and equilibrium. If you remember from yesterday, diamonds are not forever. Yeah, that's true. If you remember from yesterday, the equilibrium constant, we have our relative concentrations of our reactants, or for reactants below our relative concentrations of our products, right? That's our K value. Now, we know that for a reaction to be thermodynamically favorable in the going in the forward direction, K has to be greater than 1. We know that the temperature is the temperature, pressure, and concentration can all shift the direction of this reaction. But we also know this very interesting formula, right? Delta G equals negative R times T times the natural log of K. And in this case, not that it really matters. I don't think you'll have to be expected to do any calculations with this formula, but this is just 8.314 joules per mole Kelvin. And this should also be in joules per mole, preferably. Right, link. You won't really have to use this formula much, but conceptually it's good to know. So let's think, guys. If the natural log of k, if k is greater than 1, what is the natural log of k? Is it positive or negative? Is it positive or negative? Positive, exactly. So delta G will equal negative RT times a positive number, which is a negative number. But now, conversely, guys, if K is less than 1, as in the reaction is thermodynamically unfavorable, right? We have K less than 1. What's natural log of K? Natural log of K is less than 0. So now delta G equals negative RT, just constant values, times a negative number, which is just RT times a positive number, which is greater than 0. So delta G is greater than 0. Now you see what this means? You can connect this to understand that if delta G is greater than 0, your reaction is unfavorable. And if delta G is less than 0, your reaction is favorable. You are not cooked. Don't worry. If you understand this, you are good. All right, let's do a practice FRQ. I forget, am I supposed to give them time to do the FRQ by themselves and then go over the answers?
Yeah. I would
Yeah,
give
okay.
them
I'm gonna
like-
go get
yeah.
water. So I'm gonna
Yeah,
start
yeah,
the
of course.
timer.
Okay, I'll yap. You're good.
Okay, yeah. All right, guys, knock yourselves out with the FRQ. Don't actually knock yourselves out. There's gonna be a lot of explanationing
Wait,
happening
yeah.
afterwards.
Please don't knock yourself out. That'd be awkward.
All right, I'll be right back after I get some water.
I'll yap, Israel. I love yapping. I'm the yappiest of the bunch, I guess. I don't know. Is the timer gonna start? Oh my god. Let's see. If the timer doesn't start, I'm starting one on my phone. Just saying. Oh, it started. We're cool. All right. Let's see what to talk about. What do you guys want to talk about? We've had a lot of on-topic yapping because I've done a lot of it. Me and Yash especially have done a lot of chemistry yapping. So I feel like we can diverge and do a little bit of non-chemistry yapping. So tell me what you guys want to know. I'm an open book or something like that. I'm not actually that much of an open book, so don't ask me weird things. That'll make me uncomfortable. We don't need to talk about my new job search. My new job search is actually Anuva's position. Fun fact, after she leaves. You know, she's getting really old now, so she's gonna retire soon too.
You're literally going into dermatology for Botox. I don't want to hear it.
Her title's a teacher host because she's like a teacher. She's been a teacher. She went to Fremd High School in Palatine, Illinois. That's where she teaches.
Okay.
She's like 40, you know, she's like pushing like 40, 44, 45. Wait, did you actually go to middle school in Palatine? There's no way I called that. Anyway, my bad. What? Sorry.
I hired Rahi because I've been playing chess with him for like a while. I visit him at the nursing home.
The nursing home is
he's around like
crazy.
83.
The nursing home is crazy. No, I'm at the nursing home because I'm a diligent volunteer. You can't relate. You don't like people enough. That's actually kind of messed up of you. I can't lie.
Okay.
Palatine's not in the middle of nowhere. It's very much like a general mid-sized Chicago suburb. I don't know why you'd say that.
Naperville?
Yeah, exactly. It's literally like Naperville except small.
Guys, answer the actual chem questions if
Okay.
there are any.
All right. don't spend too much time messing around in chat, guys. You have to actually do the FRQ. All right. Did we ever take the AP Chem exam? Yes, we all took the AP Chem exam. Has anyone taken a practice test recently? I hope some of you guys have. Chest. I took one today. Skincare routine.
Okay,
What's Rahi's
my
skincare routine?
Dude,
That's an insult, Rahi. Sorry, this is chem related, but is sorry, this is chem related. No, that's
Sorry, this is chem related.
Is increasing microstates the same thing as having more moles? When you have more moles, yes, you do increase microstates, but when you're increasing microstates, all that's really saying is that you just have more ways to arrange crap. So say you have a red and blue book, you can either do red blue or blue red. But if you're red blue and green book, now you could do red blue green, green blue red, green red blue, more microstates, right? Is teaching on Fiveable a retirement home for people who got a 5 at AP? Yes, teaching on
Yeah.
Fiveable is a retirement home.
It is. 100%.
I feel like AP Chem ages you though. Like that class put me through hell and back.
Oh, I didn't think the class wasn't fine for me.
I think it was just my professor. My professor was
Yeah,
just like
probably just a bad
incredibly
experience.
just like difficult.
Mhm.
Like all of my tests were like you only had enough time if you like knew everything.
Yeah.
So yeah. You can't even write my name right.
Oh my god, it autocorrected. Sorry. Whoopsie.
Actually, I'm gonna have like no wrinkles when I'm like 60 because like my skincare routine's so
Wait,
good.
W skincare routine actually? That's good.
Yes, Tessa, you can use Lechat. Lechat and an FRQ is actually preferable in almost all cases. Or you can derive the temperature dependence of a reaction, which is also good. Either way.
Please practice the FRQs. Like that is like the one thing that I think truly carried my 5 is that like for several weeks before the exam, like every single weekend I would sit down and just like do a bunch of FRQs of like the past FRQs. Just because like while like the style of questions seem to be like consistent, so if like they're testing you on like a titration or something, then like while I won't say like the wording of the question similar, it will like still ask you like if it's asking for like the equilibrium point or something, equivalence point, oh my God. Then it's gonna ask you in a similar way.
All right, Nora, you're not supposed to use Lechat when talking about Q and K. You can justify these things by using Q and K, or you can justify by using Lechat. Really, as long as you can justify it in a valid way and get the right answer, you're gonna get all the points. Let's not compare our MCQ scores, guys.
Yeah, guys, we're here to support each other.
Do MCQs quickly. Eventually they'll all be like the same to you, and like we'll get them pretty fast.
Yeah, I would say just practice.
I forgot there's one scenario where AP Classroom told us not to use Lechat. Now I can't think of a scenario where using a simpler principle doesn't help. Lechat's pretty much okay. There are like these very fringe cases where Lechat is invalid, but you're not gonna see that on the AP Chem exam really. Yeah. Don't worry. I'm not comparing. I'm just saying it's fine. It's fine. Just let's keep it more content focused. And actually, I can't really say that with my co-host.
Okay.
But still, what is the 2-pass strat? I've never heard about that.
Yeah, I don't know what that is.
I have no idea what that's. You can see
Yash,
like Yash
what's
is
going
like
on with the timer,
Googling
by the
it.
way?
The
It's
timer?
because he's on a different
Is it when you
tab.
click
Oh,
off the
it's different.
screen? Yeah, okay,
Yeah.
okay. I figured.
That's okay. I have no idea what the 2-pass strat is.
Like, if you can explain the 2-pass strat.
Oh. I mean, like I personally do that where it's just
Oh.
like I will like circle questions that I like know I'm taking a little too long on, and then I'll go back and do them. But like that's only something if like you regularly do MCQ, like I feel like on the faster side. Because if you take like a really long time normally to do MCQ, then you're gonna run out of time and not be able to do the hard ones.
Yeah, it just depends.
I was gonna say it
how
depends
you
on the
do
test taker.
questions.
Yeah, it depends
Yeah.
on the kind of test taker that you are. It's just like if you are one of those people that like generally like takes their time, like thinks through each question, then keep doing what you're doing. That's fine. Don't like try to skip stuff then because you're gonna run out of time and then it's not gonna work. But if you're just someone that generally like skims questions faster, then yeah, I think that's not that bad of a idea. I personally don't use that strategy, but I could see like situations in which people would for sure.
This webinar is probably gonna be over
So
closer to
originally,
10:30.
yeah, it's probably gonna be 10:30. And then like if you can't stay, it's okay. We'll have a recording. Hopefully, since tomorrow we're gonna be on Zoom, we won't have any issues. I think there's 7 FRQs, 3 short, 4 long, or the other way around, something like that.
Okay, so Adam Lou, that's a common misconception. I'm pretty sure in chemistry they do error carried forward. So if you get like part A, the part is like find the molar mass, and the rest of the A, B, or B, C, D, E, F, G all require to use the molar mass, and you get part A, the molar mass itself wrong. If you use the incorrect value of the molar mass, and you continue to you do all the work correctly, you get the right answer, they will count it all as correct.
Yeah.
So
You'll get full points even if your answer is not technically correct, but it would be correct given that you've used your first incorrect
error
answer.
carried forward. Yep.
Yeah.
Calc doesn't do that, I'm
let's
pretty
move
sure.
on
Yeah, they don't.
to the
All right, so let's get started, guys. 1 second. The spot has the mouse. This is not. All right, rare calls door W. That's correct. That's correct. Oh, I don't want to show you guys the answers. Okay. So in this case, actually, let me just do that. We don't have that much time. I don't have to actually mathematically show everything too. All right, in this case, you can obviously see that this bond is present here and it's not present here. Remember that breaking a bond takes energy. So it takes energy. You need to add energy. So delta H must be positive. So there you go. Delta H is positive. For entropy, you're going from 1 molecule to 2 molecules. More molecules, more microstates, more entropy. So that means delta S also positive. All right. All right. Interesting questions. Alrighty. Use principles of thermodynamics to explain the following questions. One of the diagrams below best represents full sentences. Don't think so. Just do if you have time. One of the diagrams below best represents the relationship between delta G and temperature for the reaction given in part A. Assume that delta H and delta S are independent of temperature. Draw a circle around the correct graph. Explain why you chose the graph in terms of the relationship. You can't just say the slope is negative. You have to actually show why that's true. All right. So what you're trying to do is you're trying to do delta G versus delta T, or versus T. H minus T delta S. Right. So now that you know that delta S is greater than 0, right? Negative delta S is the slope. Since delta S is greater than 0, negative delta S is less than 0. So therefore, the answer is the one with the negative slope. You cannot just say the slope is negative because that's what you're doing when you circle this graph. You got to explain why. Alrighty, next question. Alrighty, now here's some Lechat. All right. So in this case, a reaction mixture of N2O4 and NO2 is at equilibrium. All right, so now we can draw an equilibrium arrow here. Heat is added to the mixture. We know that this reaction is endothermic, so we can kind of think that we have heat as a pseudo-reactant, right? If you add heat to the mixture, you're adding reactant, right? So the system will shift this way by Lechat to produce more NO2. And in that case, the concentration of N2O4 will decrease, right? Similarly, we have number 2, where the value of KEQ at 25 degrees Celsius is 5 times 10 to the negative 3. Will the value of KEQ at 100 degrees Celsius be greater than, less than, or equal to this value? Now we know again that heat is a pseudo reactant in this problem, right? So if we add heat by increasing the temperature, the reaction is going to shift more to this side. Therefore, we're going to have more products. Our products are going to get larger while our reactants are going to get smaller, right? So KEQ at 100 degrees Celsius will be larger than KEQ at 25 degrees Celsius because we're going to see a shift towards products, right? Kendrick just dropped again. Would an acceptable explanation to CI be that when you increase the temperature, the forward reaction will be more favorable since delta G is more negative, so there will be more products? Yes, if you justify why delta G will be more negative, yes, that'll be valid. All right, let's move on to the next one. Alrighty. Using the value of KEQ at 25 degrees Celsius given in part C2, predict whether the value of delta H is expected to be greater than, less than, or equal to the value of T delta S. All right, this is an interesting question. It's asking us, what is the relationship? Like, is this greater than, or less than, greater than, or equal to T delta S, right? So at 25 degrees Celsius, we know that KEQ is 5 times 10 to the negative 3, right? And so if that's true, then the reaction is non-spontaneous, right? It's not thermodynamically favorable because K is less than 1, right? So if K is less than 1, then what does that mean? That means that delta G is greater than 0. Now, if we know that delta G is equal to delta H minus T delta S, and all that is greater than 0, we know that delta H, just doing algebra here, has to be greater than T delta S, right? So we can say this is true. All right, is the FRQ good for everyone? Are we good? Can we move on? I don't get the last one. Okay, basically, KEQ less than 1, right? This is less than 1. Delta G, if this is less than 1, delta G is greater than 0, right? Are you following Jasmine and Shen and Diane? Why is small k going to be positive delta G? Okay, so if k is less than 1, then the reaction is not spontaneous, right? If the reaction is not spontaneous, that implies delta G is greater than 0. Yes, because it doesn't precede the right, exactly. Now, if delta G is less than 0, it's equal to H minus T delta S still. And if this is all greater than 0, we can just say delta H by algebra is greater than T delta S. Can we use the arrows to say increasing on the AP test? Same thing with down arrows. I wouldn't do that. I would write words. So is K less than 1, G greater than 0? That is correct. And the opposite means G less than 0. That is correct. And you are correct. All right, I'm going to move on to the next one now. Oh, it's a break. Are we running through this break, Anuva? What is the call on this? 2-minute break? What is the time? Let me check my phone. 9:45. Okay. 2-minute break. What do you think, Anuva? Is Anuva even here? Is Anuva here?
I think 2 minutes. I'll answer for her because I don't know. She disappeared, I guess.
Everyone in the chat saying skip break, or most of the people.
I don't want to skip the break. I need to stop talking for a second.
What's next? Is it a quiz?
Electrochem. It's like a whole presentation.
Yeah, okay. You can take like 2 minutes.
I'm reading chat, by the way. It's a skill, you know, reading
A
chat
skill.
and presenting.
Yeah. Okay, electrochem it's not too long.
Yeah. How many slides?
Like 12.
Okay. Remember, when we break bonds, it costs energy to break bonds. Because forming a bond Remember that energy versus internuclear distance chart? Exactly, Nikki. Takes to break and freeze to form. All right, let's just get started. I want to get started. Alrighty. So we're going to start with coupled reactions, right? So coupled reactions basically just mean reactions that are both, like say you have a reaction that is unfavorable, right? It's endergonic, costs energy. You can couple that endergonic reaction with an exergonic reaction, a reaction that frees energy, that releases energy, to have a net reaction that is overall exergonic and releases energy, and make that overall reaction spontaneous. This process happens a ton of times in your body. All right, that's not important. Let's move on to the important part of Unit 9, the second important part of Unit 9, which is electrochemistry. Electrochemistry is basically just redox processes and using them to generate or use electrical energy. Now, important. Anode oxidation, cathode reduction. There's a lot of common mnemonics people use to memorize this. One super popular one is ANOX, red cat, anode oxidation, reduction cathode. Just know anode oxidation, cathode reduction in a galvanic cell. Electrons travel from the anode to the cathode. You can remember that ANOX, red cat, anode comes first, so electrons go from anode to cathode. Here's a diagram of our electrochemical cells, also called galvanic. Galvanic just means your E is greater than 0. So not all electrochemical cells are galvanic, I believe. Okay, so important things to note about your actual galvanic cell right here. We have a salt bridge. In the salt bridge, the positively charged salts flow into the anode. Just by looking at the galvanic cells, you can tell this by I'll give you the redox potentials for silver. It's the E is like 0.8 volts, and for copper, I'll tell you them. You can see that the E for silver is greater than the E for copper. And so the silver is the cathode and copper is the anode. So the positively charged ions in the salt flow into the anode. Then, wait, this is incorrect. Hold on. This is incorrect. The positively charged ions from the salt bridge flow into the cathode, while the negatively charged anions flow into the anode. The electrons go from the anode to the cathode, always in this line. In a galvanic cell, always goes like this. The anode is always negative. If the E is greater than 0, the anode is negative, and the cathode is positive. This is negative. This is positive. All right, that's a quick diagram. The reduction potentials are positive. Yes. Well, I just deleted this slide. So anode is always on the left. It does not matter which side the anode is in. Conventionally, it's on the left, yes. All right, galvanic or voltaic cells versus electrolytic. Anode is just negative by convention. So for galvanic cells, your E cell is greater than 0. That means your reaction is spontaneous. There's a relationship between E cell and delta G. If you hear the word spontaneous, you should always think delta G, by the way. Delta G is equal to your NF times your E cell. since this is a negative number, if E cell is greater than 0, your delta G is less than 0. Anode is negative just because, like, it's just convention. If it's greater than 0, your delta G is also less than 0, so your reaction is spontaneous. Now moving over to here, an electrolytic cell, this just means you need to add electricity to make this reaction occur. That means your E cell is greater than 0, right? Ian, for your question, think about if you're moving electrons to the cathode, because remember the electrons from the anode to the cathode. Those electrons need to be evened out by those Na+, right? Need to be electrically neutral. Those Na+ move over to even out the charge that the negative electrons bring. So if your E cell is greater than 0, your delta G is greater than 0. If the salt bridge is removed in a galvanic cell, it stops working because your solutions become electrically non-neutral. I don't know what R is referring to. I don't know. That's why I skipped it. So let's just imagine this doesn't exist. Okay, I don't know what R is referring to. It's probably something experimental. All right. Salt bridges are not used in this. It's just one solution. Can I re-explain how salt bridges and ions move to the cathode to anode? Yes, I can. 1 second. All right. Rate. Yeah, you can't really worry about rate in this situation. All right. So your electrons are going this way, right? Your electrons are going this way. So if electrons are coming down into here, this positively charged sodium will come over here to balance out the charge of the electrons. You want to keep an electrically neutral solution. And remember, if electrons are leaving the left side, the anode, if electrons are leaving the anode, your negative charges will come here to balance that out. All right. That's how you can justify the movement of the ions. Alrighty. Here's an example. We're going to do some calculations here. We have a redox decomposition. This is an electrolytic cell, right? So can we in chat say whether E cell will be greater than 0 or less than 0? Yes, we are going to be going over how to calculate E. This is an electrolytic cell. Will E cell be greater than or less than 0? I'm seeing mixed answers. All right, yep, less than, exactly. Because if it's less than 0, what does that say about delta H? Is delta H greater than 0 or less than 0? If E cell is less than 0, is delta H, not delta H, delta G greater? Yes, delta G is greater than 0. Exactly, that makes it a non-spontaneous process. All right. Now here are our two electric potentials. All right. So for calculating voltage, we always do it the same way. For E cell, which is our cell voltage, we do the cell potential of the reduced minus the cell potential of the oxidized, red oxed. Okay. Now, what is getting reduced in this situation? That is also cathode minus anode. Yep, that's right. Na is getting reduced. Na, is that what we're seeing in chat? All right, look, let's look oxidation states to see what get reduced. Na +1. Cl, actually let's do a different color. Na is +1 here. Now Na is what over here? 0. Cl is -1 here, and Cl is 0 over here. What's getting reduced? Reduced means to gain electrons, means for its oxidation state to go down, become more negative. What's getting reduced? Na, yep, Na is getting reduced. Exactly. Its oxidation number is going down. So given this, the E of our redox potential, our E red is what? Is it -2.71 or -1.36? Or sorry, let's erase this. And I'm going to rewrite this the way they're going to phrase this on the AP exam. Don't look at this, guys. Look at this over here. What is this E red? We're looking for E red. What is E red? I need you guys in chat to type it out. Negative 2.71. Exactly. Great job, guys. E red is negative 2.71. Now, minus E oxidized. Now, what is E oxidized? Pure elements have 0 oxidation number, 1.36 volts. You guys seem to have gotten this. And now doing this math, we're at negative 4.07. What did we? I'm not sure what they did here. Yeah, I'm not sure exactly what they did. Here, 1 second. Oh wait, I sorry. Yeah, it's a negative sign right here. Sorry guys, my bad. All right. And then you'll get your negative 1.35 volts. Would delta G be positive because of endothermic reaction? It's because that's this potential right here. It's this potential. We have to flip the oxidation equation. Yes, you have to flip the oxidation equation. They'll usually give it to you as both as reduction equations. You want it to show oxidation. Exactly, yes. Would delta G be positive? Yes, it's not an it's an endergonic reaction. You have to multiply by negative NF. Yes, that's right. Would it be possible to get these slides in? Yes, okay. I should have to speed up, guys. Sorry. Therefore, you have to use electricity, right? Because this potential is negative. Your voltage of your battery is greater than or equal to this voltage of this reaction. Sorry, my bad, Anuva. All right, cell potential and free energy. This is not the right slide. Okay, cell potential, free energy, just ignore what's all over here. And just know that for cell potential, it's this relationship, right? It's this relationship. N is the number of electrons transferred. F is Faraday's constant. Which is 96485 coulombs per mole. When you flip the equation, you do change the sign. Yes, when you flip the equation, you do change the sign. All right, this is the only equation you need to know. I don't know what's on these slides, but this is the only equation you need to know for the APs. All right. How do we determine cell potential under non-standard conditions? So remember, sometimes when the reactions progress a little bit, our potential will no longer be standard. So now AP Chem does not actually directly test you on this. They kind of indirectly test you on like using Le Chat. There's this thing called the Nernst equation. It's on your reference sheet at the very bottom, I believe. And it's just a really complicated equation, but it's just overall, it's just a big statement of Le Chat. They're never, ever going to ask you to directly calculate using this equation. They're just going to ask you to justify stuff, but you can always get away with justifying stuff using Le Chat. Do you care about stoichiometric coefficients? No, you don't. You do not have to worry about them. Remember, guys, standard conditions, as always, mean 1 molar concentration of solutions, and all standard pressures are 1 bar, which is about the same thing as 1 atm. You're at your 298 Kelvin, everything's at 1 atm, and your Q is equal to 1. How do we calculate Q? Don't worry about that. Standard conditions, Q is just 1. So when you use Nernst, could you technically also just have used Lechat? That's correct. Yes, just use Lechat in every case. Don't use the Nernst equation. They're never going to ask you to directly use the Nernst equation. Really, these questions are just going to be like, will voltage be greater than or less than? If like E is greater than E cell, the reaction is more spontaneous than what it normally is, right? That means there's an excess of reactants because they want to shift towards being products. If there's an excess of products, E cell or E will be greater, or E will be less than E cell because it's not as spontaneous anymore. Higher reduction potential is always the cathode. Yes, that's correct in the case that we're working with a galvanic cell. Alrighty. Now here we have this. So we have this equation, right? 2 aluminum solids plus 3 Mn2 plus aqueous goes to 2 aluminum 3 plus aqueous plus 3 Mn solids. And now we have to compare E cell to E standard cell when Al3 plus is equal to 1.5 molar and Mn2 plus is equal to 1 molar. So for this, all we have to do is just see what is bigger. So let's see, let me look at my pen. At standard conditions, Q is equal to 1, right? For E cell standard. For E cell non-standard, right? Non-standard. We have to calculate the new Q. Remember, Q is just the products or the reactants. So products are what? Al3 plus. What coefficient? What exponent do I put on Al3 plus, guys? 2, exactly. And on Mn2 plus? 3. Now, what does this number become? .25 exactly. Now, if we have that this Q value 2.25 is greater than 1, we are only looking at the Al3 plus. Everything else is a solid. We don't have to worry about solids, right? Solids are just 1. So 2.25 is greater than 1. We have too many reactants, right? We have too many reactants. So this reaction is going to want to shift more this way, right? And so this reaction is more spontaneous. Or sorry, if we have too many, if our Q is too large, or Q is too large, that means we have too many products. We have too many products. We have too many products. Sorry, misspoke, guys. I'm speaking for too long today. We have too many products. We have too many products. Our products are too large, right? We have too many products. That means our reaction will be less spontaneous, right? And now if E is like proportional to how spontaneous our reaction is, right? And we have less spontaneity because we have too many products. Our E is actually going to be less than our E cell standard. Does that make sense? Yes, okay, great. All right, just use, instead of using Nernst, always use like Q and Lechat for this because they're not actually trying to directly test you on Nernst. Does E less than E standard mean it is less favorable? Yes, that means. So shifting left, reactant favored reaction is less spontaneous. Yes, that's correct. All right, let me move on. All right, I'm going to skip these scenario ones because I don't think we have enough time, but you can kind of look at them real quick. You have too many reactants compared to your products, so your E cell is going to be more spontaneous. Both of these cases, you have too many reactants compared to your products. The actual numerical value of E cell is not important. It's just a qualitative, which one's greater. You don't have to know the actual value of E cell. All right, basically this is the last topic in AP Chem. This is Faraday's law, electrolysis, right? So for Faraday's law, it is just a really, really long dimensional analysis. Yeah, Faraday's. From Faraday's law, we can just calculate the charge flow based on what changes in amount of reactants and products in an electrochemical cell. So basically, for a given current that's running for a given time, we can calculate how much charge has accumulated. And from that, we can calculate how much of a product we've gotten. Or we can go completely in the opposite direction. Given the product, we can calculate like what is the charge? What is the current? Et cetera, et cetera. Now let's do a problem. Let's do an example problem. All right. Remember, for all these Faraday's law problems, you just need to know that the Faraday constant, this is on your reference sheet, by the way. 96.5 grams per mole. All right, the relationship between Q and E cell, when Q is greater than 1, E cell is going to be less than standard E cell. When Q is less than 1, you have too many reactants. And so the reaction is going to be more spontaneous. So E cell is going to be greater than E cell standard. Yes, you can use IT divided by F equals NE for these types of questions. I would just recommend doing dimensional analysis, whatever works for you. I'm going to solve using dimensional analysis. All right. So determine the mass of chromium produced when a solution of chromium nitrate is electrolyzed for 60 minutes with a current of 15 amps. All right. First, before we get started, what is the oxidation state of chromium in this compound? This is chromium nitrate +2, exactly. So how many moles of electrons will we require to do this reaction? Chromium 2+ plus Ne goes to chromium solid, right? What is N? Now what's N? Yep, 2 electrons. Great job, guys. So for every 2 moles of electrons, we'll need 1 mole of chromium. All right, let's get started, guys. So 60 minutes. This will be a long dimensional analysis, but hopefully you can get through this with me. For 60 minutes, for every 1 minute, how many seconds do we have, guys? Big question. You have 60 seconds. Remember, amps is just coulomb over second. So 15 amps means we have 15 coulombs every 1 second. All right. And now for every 96485 coulombs, we have 1 mole of electrons. And for every 2 moles of electrons, we have 1 mole Cr2+. Now, for every 1 mole of Cr, we have, I think it's 52 grams Cr. Is that correct? Can someone check that? Don't have a periodic table next to me. Okay, that's correct. All right, now do this in your calculator. I think I have a calculator next to me. I can try doing this. What do you guys get? $14.55. There's a sig figs problem with this problem, but let's just not worry about sig figs. Let's just go with 3 sig figs. And we get 14.6 grams of chromium. And that's how you do these problems. It's just really long dimensional analysis. That's literally all of it. Okay, great. Would this be an FRQ or MCQ or either one? All right, let's do this problem, guys. MCQ, I'll give you till 10:14 to do this problem. For FRQs, they'll just take off. If your sig figs are wrong, they'll take off a maximum of 1 point throughout the whole test. Oh, sorry. Well, is the stoic ratio the same just for electrons, same as N3? Yes, in this case it is. I think you guys already saw the answer to this question because I accidentally revealed it. But yeah, I think you guys would have gotten this pretty fast anyways. Diagram 1, the process is freezing, right? You're going from a like a relatively ordered liquid to a super ordered solid. Oh, you want to go back to the other problem? Okay, 1 second. What was the question? Just take a screenshot. All right. So you have a lot of order, and you're going to say with that he has even more order. So your delta S is negative. And that is a correct statement. You're welcome, guys. You're welcome. Thank your other hosts, too. I think this question is really, really straightforward. So good. All right, here's a break. What is actually next after this break? There's a quiz. Do you guys want to start the quiz now, guys? All right, I think everyone start the quiz now so that we can get started. Let me go find the link, guys. Oh, I'm good right now. 1 second. I need to find the actual link to the quiz. Nope, this is not the right quiz. Whoopsie. 1 second, guys. Perhaps this is the right one. Yep, this is our one. Everyone, let's join. Can you guys all hear the music? Can I send link in chat? Sorry, yeah, you're right. Oh, I just sent that to Anuva. Link in chat. And here's your link, guys. And my Zoom just like disappeared. Notice how Rahi isn't here. What's the best pen to use? I use this one. But like, I think there's better pens, I'm not gonna lie. But like, it's the G2 Pilot. Yeah, just because it's cheap. Yeah, I use the Dotto 7 too. But yeah, it's definitely some like really good pen that I've never heard of. It's just like the really basic one. Alrighty guys, come on, let's join in. For AP Chem, you can get away with writing in pencil. Just depends, you know.
Wait, can you guys hear me?
Yeah, I can hear you.
Okay. I actually have one thing. I don't know if someone mentioned it already, but do not use an erasable pen on the AP exam just because they like, so basically if they're, I believe if it's in too like warm of a condition or something, like for the FRQs, it can actually disappear. So don't do that. But yeah. Oh yeah. Rahi got yelled at in the senior home. Don't use an erasable pen. And then if you're using a pencil, just like make sure it's dark enough. They should provide you with pens in case you don't have it, but yeah. Yes. Sometimes they'll let you use pencil on the FRQ, but I'd bring a pen just in case. Yash, you could probably start.
All right, yeah.
We'll only do like a few questions, so.
Then the Q&A for a little bit. Then we can call it a night. I didn't check these questions. I only checked the acid-based ones. No, this is it. Let's not do this question. Yeah, don't worry about that question. That question was whack. I'll try to read the questions before we guys can answer them. That is my favorite word. Yeah, whack.
This might be like an unpopular opinion, but I love using pen for the FRQs because I just write so much easier.
All right, great job, guys. Almost 90% on this question. When you increase temperature, things get more random. They move around faster. You're increasing kinetic energy. That increases entropy.
The recordings will be for the Zooms will be uploaded tomorrow or like maybe later tonight. Because we have to have admin like physically put in the recordings, but they will be located in your My Stuff. There should be like a link to it.
What group does an element have to be in for expanded octets? Usually period 3 and greater, not group, but period. Make sure you note that's an important difference. Yeah, you're good. All right, great. A lot of you guys seem to got this question right. Production of gases. Gases have higher entropy than liquids and solids and aqueous things. So you have more entropy, the reaction is more favorable. Yeah, they do. Acid-based titrations are very popular. All right, so after this question, only 2 more questions, and then we're gonna move on to the Q&A.
Yash, what is your favorite unit?
Of AB Chem, 8 or 9 probably. I don't know.
Mine's kinetics. I love kinetics.
I think it's such an NPC answer, bro.
No, I don't think so. I did so well in kinetics. I hate acids and bases.
Okay, unit 4 might be the most NPC. Stoichiometry might be the most NPC answer.
Unit 1.
My favorite unit of measurement is the picometer. Unit 3 is so weird, bro. Intermolecular forces. They're so
Favorite
hand-wavy
unit
sometimes.
of measurement.
Unless you use like
Did
the actual
anyone
equations.
do the New York Times connections today?
Oh wait, the one with the pico, like kilo. I didn't do it today, but like I remember there's like
It
a
was
pico
like
kilo
it
one.
was like homonyms for, or not homonyms, homophones for units of measure.
Ooh.
Oh my God, Kritika.
No, you haven't done it, bro. Okay, looks like you guys all got this one right, so I'm not gonna really explain it. But you go from solid to liquid, more entropy.
You guys are goated. Heck. Oh my gosh. I feel I need to like I wanted to Never mind. No, we're not gonna do the whole
yeah,
quiz.
Yeah. This is our second to last question.
Yeah. So tomorrow we're gonna be doing like hella FRQs, or sorry, I probably should not be saying that on stream. We'll be doing a lot of FRQs. We'll be doing one FRQ per unit tomorrow. So we have a lot of practice for that. And then we also have what do you call it? So we have a little bit of like content review in the beginning. It's very general. I will say like the graphics for those, I made them inspired by last year. But yeah. Yeah. So there's that. And then we'll have a whole cram quiz ready for you guys, but if you guys would rather us do like Q&A, we can do that, but we'll have that ready just in case.
All right, yeah. So lower free energy change, the more negative the free energy change, the more spontaneous this reaction is. Anya, yeah, if you just tell us tomorrow and you link in everything, we can try doing that.
Okay. This will probably be our last one, and
Last
then
question,
we'll do a little bit of Q&A
No,
before.
we're not doing this one. This one's not even for this year.
Oh. Yeah, I forgot I was working, definitely. I hope this oh my gosh, oh my god, I'm like so tired right now. I hope this has been helpful. Yeah, you guys should definitely drop in the chat how, like on a scale of 1 to 10, how confident you guys are. Yay! Oh my gosh, we're doing so good. Okay, Nika, don't make fun of me.
it's like 10 in the
It's been a
sevens or
rough
something?
day. It's been a rough day.
How much harder is it to get a 5 than a 4? I think it's like relatively similar, isn't it?
Yeah, I mean, I don't think it's like what percent do you need for like a
Like 60% to 70% or something like that? I don't know. You
something?
can definitely do
Yeah,
it
I
though.
think
You
there's
got
like a really good curve for AP Chem. I know last year's was not that bad, I didn't think. Well, obviously it wasn't that bad for you, but
This question was a little bit harder. So thermodynamic versus kinetic control. Remember, if we look at that graph where we have those two different equations, one of them has a lower activation energy than the other, but also has a greater or a smaller change in Gibbs free energy, right? So thermodynamic versus kinetic control, basically, if you add a catalyst, the reaction rate will change. So all of a sudden, you're going to have different energy profiles because your mechanism will change and your activation energy will change. So that's going to change. And so you can rule out A. B, if you let a reaction go on infinitely for an infinitely long time, you're going to have the reaction achieve perfect thermodynamic equilibrium, right? So that's going to change. That's going to change whether you're under thermodynamic versus kinetic control. So you can cross out B. You guys seem to have mostly eliminated B. D is another commonly picked choice from you guys. The temperature with the reactions carried out. Remember, temperature influences rate of reaction and influences the thermodynamic quantities of the reaction. So the color of the reactants is pretty quickly, and obviously the choice. Also, color of reactants doesn't really matter much for much of anything other than kind of observing what happens. Yeah. All right, does that make sense, everyone? All right, great.
yeah,
I think we're done with the
probably
quiz.
do Q&A. Yes.
All right, Q&A.
Okay. Everyone drop questions in the chat. Stats was not that bad. It was honestly like
Beer's law is absorbance equals that absorptivity constant times the length of the cuvette times the concentration. And we can go over it in detail tomorrow.
oh, we should probably go over. Yash, have you done that practice question where it's like, how does the what is it? How does like the absorbance get altered when there's like a smudge on the cuvette.
Oh, here. Okay. So I can talk about that more tomorrow, but if you just want to hear really quickly, if I put my like finger on the cuvette, I'm gonna make a stain on the glass, right? And absorbance is basically a measure of how much of the light that passes through that the glass absorbs. I put a stain on the glass, less light's gonna pass through, right? That means the absorbance is gonna go up. If the absorbance goes up, that means that the measured concentration will also go up. So you'll have too much concentration. I've never really used it in AP Chem. I think it's like one FRQ in class one time maybe, but yeah, not frequently. I don't think it was on my exam either. I don't remember. How do you choose the central atom of inorganic compounds for loose structures? Usually you can get away with just putting the least electronegative atom in the center, minus hydrogen. How do you know what increases or decreases voltage or when it increases or decreases? You're going to increase voltage if you're going to make the reaction more spontaneous. You're going to decrease voltage if you're going to make the reaction less spontaneous. You can justify that using Le Chat's Lechat. So if you add a bunch of reactant, your Q is a less than K, or your Q is less than 1. Your reaction will be more spontaneous, and therefore your reaction will have an E cell that is greater than the standard E cell. Why is NBr5 an impossible molecule? It's an impossible molecule because nitrogen is bonded. Okay, wait. Okay, I'll just take it at face value. NBr5 is impossible. Like a covalently bonded 5 Br to 1 nitrogen means that nitrogen will have 10 electrons around it, right? It'll have 10 electrons, and nitrogen cannot expand its octet since it's in the second period. How exactly in words should we explain with Le Chat? Write out Q. Calculate Q. Say Q is greater than, or Q is greater than less than K, and then you can just say that. Therefore, say like we can write the Nernst equation too, and then just say Q is less than greater than K, so E cell is whatever. Why are we talking about calculus?
Okay.
Is formal charge important to
Um,
know?
We could do a review on galvanic cells tomorrow just because like we are very short on time. So I think we could wrap it up tonight. And then any like general questions that you have, such as like review of topics and whatnot, we can do tomorrow. So
All right, kinetic control is basically just, this is my last two Q&A questions. So kinetic control is basically just the only reaction you only let the reaction that goes, the only reaction that you let to go forward is the one that has the lower activation energy, the reaction that goes faster, even if it's not the more spontaneous reaction. We did one example of solving for concentration given K's p-value yesterday. We can do more tomorrow if that's a problem. And for practice questions, just look Google. Like Khan Academy helps. All right.
Okay. Thank you guys so much for coming tonight. And we will see you guys for our finale tomorrow. So
bye-bye.
Have a good night.
Good night.
Sleep well. Bye.
Bye. Hopefully it helped.
Yeah, and then for host, we're not going to do a post session huddle because I don't feel like doing one. So I will see you guys tomorrow.
See you tomorrow. Bye.
Bye.